Platinum uplift likely as particularly China, California gear for green hydrogen mobility.
This audio is brought to you by Aztec Industries, a global leader in manufacturing equipment for infrastructure, including asphalt production, construction, and material processing, driving innovation and sustainability.
While South Africa's latest green hydrogen development is a request for information, RFI, by the East London Industrial Development Zone for a greenfield green hydrogen project, major green hydrogen advances are being reported in particularly China, but also California. China's green hydrogen industry experienced explosive growth in April, Fuel Cells Works reports on LinkedIn, with new capacity exceeding 3 million tons. The industry covers the entire value chain of hydrogen production, storage, transportation, and application, breaking through large-scale development bottlenecks through diversified approaches and achieving benchmark applications in transportation and industrial sectors. China's green hydrogen sector is reportedly on the cusp of rapid development, potentially blossoming into a $1.64 trillion emerging industry as the country strategically prioritizes hydrogen as a cornerstone of its future energy system. At the same time, platinum-catalyzed hydrogen fuel cell trucks are reportedly about to hit the road in a big way at one of the busiest port areas in the US, Los Angeles and Long Beach. Backed by a power trio of companies, this new wave of clean transportation aims to move goods while cutting back on pollution in a region that really needs it. Also interesting in China is that buyers in Shenzhen's over-the-counter market are paying 5 yuan to 6 yuan per gram or $24 per ounce above the Rong Tong Gold (RTG) price to secure platinum. Getting back to the latest South African green hydrogen development in East London, information is being requested for work packages including a 10 MW electrolysis platform, hydrogen refueling dispensing, and 3 1 MW hydrogen fuel cells, which are generally platinum-catalysed. While the project will assess a 20 MW solar system as a separate work package, participants may propose solutions for this package as well. RFI participants will be supplied with the formal invitation to bid pre-front-end engineering design, FEED, document from which the FEED study will be compiled. The project is described as being currently at the FEED stage, with the environmental impact assessments in process for the green hydrogen production plant and solar photovoltaics. The project will encompass the complete green hydrogen value chain. Proven desalination technology will be used to treat seawater to produce water suitable for electrolysis, while surplus water will be supplied to commercial customers. Electrolyzers powered by renewable energy sources will be used to split desalinated water into green hydrogen and oxygen. Infrastructure will be installed to compress, store, and deliver the green hydrogen reliably to identified off-takers. The green hydrogen produced will support the decarbonization efforts of various sectors in proximity to the hydrogen production plant, enabling industrial players to remain globally competitive as the world moves to adopt carbon border adjustment mechanisms that will price carbon into production costs. Meanwhile, Hydrogen Energy reports that China's green hydrogen electrolyzer orders in first 4 months of this year exceeded the total for whole of 2024. More than 2.4 gigawatts of electrolyzer orders from 31 projects were publicly announced between January 1st and April 30th, and some expect this number is to nigh double in the coming months. In the UK, Wrightbus reports that the cost of hydrogen bus ownership will be on par with battery electric, but with the added advantages of considerably shorter 8-minute refueling and a 50% longer range, making platinum-based hydrogen fuel cell buses a scalable solution for operators with demanding duty cycles. As the UK's leading zero-emission bus manufacturer, we welcome the plan to scale up domestic hydrogen production, build local supply chains, and cut 1 million tons of carbon emissions a year, Wrightbus stated on LinkedIn. The testing of Daimler's hydrogen fuel cell truck as being just the beginning, with 100 heavy-duty truck involvement on the way. Customers who want to be at the forefront of the drive system revolution can test the future of road freight transport with us as early as the end of 2026, Wiedmann and Win's MD Dr. Mika Lege is quoted as saying. A related project is receiving €50 million in funding from the German federal states of Baden-Württemberg and Rhineland-Palatinate as well as the German federal government. Australia Green Hydrogen. Designed in Australia after 4 years of intense innovation and engineering is a patented new green hydrogen system that cuts costs, boosts efficiency, and allows for gigascale production. Just as standardized shipping containers revolutionized the global shipping industry, the P2H2 node standardized architecture will streamline the green hydrogen industry by replacing bespoke projects with a uniform approach, Intercontinental Energy stated in a release to Mining Weekly. The system is said to collocate gigascale hydrogen production with wind and solar farms, enabling power to be used where it is generated. Toyota on China. In an interview with the Financial Times, Mitsumasa Yamagata, president of Toyota's hydrogen division, pointed out that China is pulling ahead in the race for heavy-duty hydrogen-powered transport by producing hydrogen vehicles at scale, delivering cheaper hydrogen, and rapidly expanding its refueling infrastructure. China is the most advanced country in the world for hydrogen trucks, Yamagata is quoted as saying. What makes them so advanced is that the Chinese government has ordered the conversion of key logistics routes into hydrogen corridors. Last month, Chinese state media highlighted the launch of the country's first interregional hydrogen truck corridor, a 150 km route between Chongqing and the southern port of Qinzhou. Yamagata also drew attention to rival battery electric vehicles putting severe strain on power grids and not being appropriate for transporting heavy goods over long distances. Hydrogen, on the other hand, was highlighted as offering a compelling alternative, particularly in China, where it is significantly cheaper. A kilogram of hydrogen in China costs between 500 yen and 1,000 yen, roughly $3.50 to $7, compared with 2,000 yen in Japan. This price advantage is said to arise from large-scale hydrogen production, particularly for the decarbonizing of steel. Yamagata expressed belief that there is still time for Japan and other countries to catch up, but would need to move quickly. We don't have much time left. It's important to move quickly, Yamagata concluded. In 2024, China sold more hydrogen fuel cell buses and trucks than the rest of the world combined, with 7,069 units, according to data from Interact Analysis. In Sweden, a video has been showing the arrival of a hydrogen locomotive, and in Lithuania, engineering, procurement and construction contractor MT Group has signed a $11.3 million transaction to deliver what will be the first green hydrogen production facility in Vilnius. Getting back to California, it is reported that hydrogen fuel cell electric vehicles, which are generally platinum-linked, are officially hitting the streets of Riverside. This follows the launch by the University of California, Riverside, in collaboration with the California Air Resources Board and Mobility Development Operations, of the Riverside Clean Air Car Share, a hydrogen-powered car share program. The World Platinum Investment Council reports that Accelera by Cummins has launched large-scale electrolyzer production in Guadalajara, Spain, to boost Europe's green hydrogen transition. The €50 million facility produces up to 500 megawatts of platinum-based proton exchange membrane (PEM) electrolyzers a year. Sustainability is built in, with rooftop solar and geothermal systems meeting up to 70% of the site's energy needs. Spanning 24,000 square meters, the facility involves an investment of €50 million into an initial production capacity of 500 megawatts of PEM electrolyzers a year and are designed to facilitate scaling to beyond 1 G as demand grows.